All right, hopefully you did well on your test. We had one perfect test in here and several A's, several really good tests. So hopefully you also did well on your test if you're watching on video. We're going to take our speed test next, our next speed test. Speed test 24. So if you would open up your speed drill booklets to the bottom of page 10, speed test 24. We've got some more multiplication of decimals like we practiced before. There's a few long division problems, one of which has decimals. Remember to use estimators. Real quick, on number 6 class, what's the estimator we should be thinking? A 6, because the 8 would bump the 5 up. On number 7, what estimator should we be thinking? 2. What about on number 8?
7.
We should be thinking of a 7, right? We also have some really easy division problems on 9 and 10. Okay, don't miss those two, right? Go and get those 2 easy division problems on 9 and 10. But you have a little extra time. One of your longer speed drills, you've got 4.5 minutes for it. Work carefully, work accurately, be smart, right? Work the easiest problems first, but 4.5 minutes, and you may begin. All right, go put your pencils off your desks and exchange with the person behind you, person in the back. Bring yours to the front. Go and get out a pen and sign your name at the bottom of the page as the grader. Get out a pen, sign your name at the bottom of the page as the grader. Most of the multiplication, really easy. Last two division, really easy. Most of your time was probably spent on those long division problems. So we'll see how we did on these. Going across the top row, first of all, not hard as long as you remember to put 2 decimals in your answer, 0.48. Number 2, not too bad. Just remember 1 decimal place in your answer, 88.4. For the next one, not bad. Just remember 2 decimal places, 0.3 or 0.30. For number 4, this one a little bit more involved. Obviously, got 3 digits to multiply. Make sure we put 3 decimal places. Still not too bad. 349.377. Again, 349.377. And the last one, 5.3884. 4 decimal places there. 5.3884. For the next row, going across, number 6, when you divide it out, it works out evenly to 629. 629. For number 7, you get 443. 443. For number 8, we need to move the decimal backward 1 place in both the dividend and our divisor and dividend, and we get 5.07. 5.07. Number 9, 82. Probably do that in your head. 3 goes into 24 8 times, 3 goes into 6 2 times, boom, you're done. And number 10, if you remember that when you divide by 10, you just knock off a 0. Super easy there as well. You just get 19. 19. These are 10 points apiece. Figure the score, put it in the score blank. Also, put it in the blank next to where it says speed drill 24. Toward the bottom of that first page. Put the score both places, then return to the owner. Put the score both places, then return to the owner. And owners, take a look at your scores. We had a 100 last time. I think it was Corey. Any hundreds this time? Any hundreds today? How about 90s? Just missed 1. 90s. Ooh, 80s? 70s? Ooh, questions. Yes, ma'am. Number 4. Let me flip back to it again here. Yeah, the 9.17 times the 38, 0.1. Well, obviously 1 times anything is itself, so the 917 is easy. Don't forget to put the 0. That's a 56, carry the 5. That's a 13, carry the 1. That's a 73. I keep trying to write the wrong digit first. 2 zeros. Then the 3, that's a 21. That's a 5, don't carry anything. And that's a 27 when you add 9, 4, 3, and then 3 decimal places. So 349.377. So those are your partial products. 917, 73,360, and 275,100 are your 3 partial products.
The 3 behind the decimal was a 6.
Right there. Oh, I'm sorry. All right, any other questions? Pass them forward. If you would, please take the textbooks out, open to page 176. We'll pass those forward. If you would, please open up your textbooks to page 176. We're going to continue our discussion of geometry as we go into chapter 5, but we're going to begin looking at a new concept today. I say new, shouldn't be new to you. It's new for us this year, but all of you should have talked in your elementary years about something called area. How many remember talking about area? I've actually kind of referenced this already when we talked about this room, when we talked about perimeter, right? We said perimeter, class, is the distance around the outside of a polygon. So I said for this room, if you look at this brown base molding that probably needs to be replaced, the brown base molding that goes around the room, we would need to know the perimeter of the room before we ordered, right? But if we're ordering carpet, carpet doesn't just go around the perimeter of the room. Chair rail wood, base molding wood, if you were putting crown molding across the top, or even if you were putting something like, ever seen a room that has just like a little tiny strip of wallpaper across the top, like a border or something like that? I mean, in that case, you know the perimeter of the room. But if you're carpeting the floor, class, we would need to know the area. That's what area is. Area is the space within a polygon. If you want to write that in the side margin of your book, it's the space within a figure. the space within a figure 1, page 176. Ben, you'll want to write that in the side margin of your book, like I just said. The space within a polygon is the area. And you need to know that area is always measured in what are called square units. Area is always measured in what are called square units. Now, here's the problem. If you have a goofy looking shape, can you always fit little squares into a goofy looking shape? No. But there are still somehow square units within the shape. Does that make sense? So as we talk about area, we're going to have to figure out a way to talk about square units inside weird looking shapes. But if you have something like a rectangle, since its sides are all perpendicular anyway, it's really easy then to subdivide this into little square units. You just draw a bunch of lines perpendicular to each other and equally spaced out. That's not too bad, right? Pretend these are equally spaced out. And then you go the same thing across the other way. And again, imagine these are all perfect. If this were computer generated, we certainly could. You see an example in your textbook of one of these. And then we just have to count how many of those little squares are there, right? So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's really, really slow and painful, isn't it? Now, we could do that. If you look in your textbook there, they did that on one of their drawings, right? They have that little, whatever that unit of length is, and of course, the little square unit would have that unit of length all the way around, and they counted 28 of those little squares. We could do that, couldn't we? By the way, we talk about square units, right? You could have square inches, square centimeters, square feet, square whatever, right? A square foot, for instance, the science lab. You ever looked at the floor? You notice it's made up of lots of little squares? It is. It's not carpet. No, that's why the chairs make such loud noise when they say, or the stools make such, but they're little squares, right? Each one is approximately 1 foot on each side. That's what a square foot would be. So what about a square inch? Well, if I could draw it perfectly, it'd be 1 inch all the way around. That would be a square inch. A square yard would be if I took a yardstick, measured down a yard, measured over a yard, that'd be a square yard. How many of those little tiles in the science lab, for those who've been observant, do you think you could fit in a square? Imagine, let's just say this is a yard. It's pretty close. And let's just say this is a yard there, okay? And we come up and we just missed this, okay? Let's just say that's a square yard. How many of those square foot tiles would fit in a square yard? Well, let's see, we got 1 square foot there, we got another square foot there, we got another square foot there. Does that help you to visualize how many, class? 9, right? You can fit 3 square feet this way, and then 3 square feet that way, so you can 3, 6, 9 of them, right? Okay, what about in a square foot? How many square inches could you put in a square foot? What do you think, Ben?
A lot.
A lot, you're right, there are a whole lot, over 100 in fact.
12?
Well, we could fit 12 this way, but we could also fit 12 that way. So it'd be 12 rows of 12, class. 144. Now, rather than counting all 9 of these tiles that would fit in a square yard, we could look at it this way. There's 3 tiles that way, 3 tiles this way, and we could just multiply the 3 times 3, right? Same with the 12 rows of 12, right? 12 this way, 12 that way, 12 times 12, 144. If you're finding the area of an actual square, like a square yard, a square foot, a square inch, the area of a square, and I think you'll see this in your textbook there, the area of a square is simply, and you might remember this from your junior high, side times side. Or, since a square has the same length, what's a faster way to say side times itself, class? Side squared. And that's the way now that we're in junior high, we're going to say the area of a square. Area equals side squared. You see that in bold at the bottom of the page. But what about a rectangle, like what you see in your textbook there with the little yellow squares? Rather than counting 28 squares, we could have just counted across how many, class?
7.
And down how many?
4.
And just multiplied 7 by 4. That would have given us 28 a lot quicker, wouldn't it? So with my rectangle here, let's just assume for sake of illustration that it's perfectly done. Okay, it's obviously not, but let's just assume. Count with me, class. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so there's 11 that way. How many up this way? 1, 2, 3, 4, 5, 6, 7. So how many square units are in that rectangle, class? 77 square units. Mark, write this off, or actually put a star next to the bold statement. It says all area measures are in square units. All area measures are in square units. So let's just say this is a scale drawing of a, I don't know, maybe a bathroom or something. This is the layout, this is the dimensions of a bathroom. 7 feet this way by 11 feet that way. Well, if there's 11 feet deep and then 7 feet wide for this bathroom, and of course we put a sink and a toilet and a bathtub and shower and all that stuff, right? We put that all in the bathroom so we could use it. But what would be the dimensions of the room? Well, we'd multiply 7 times 11, class.
77.
But we would also multiply feet times feet. Well, A times A is A squared. S times S is S squared. Guess what feet times feet is? Feet squared. And we could say our answer is 77 feet squared, or 77 square feet. Either of these mean the same thing. Now, stop though. Mathematicians are lazy. Which is the lazier way to write it, class?
Top one.
That one, feet squared. Also, interesting to note, metric units they never use SQ with them. We never say square centimeters or square meters. We would always say centimeters squared or meters squared. So, if you decide to do this for US and you have to do this for metric, you have two things to remember. Mathematicians are lazy. Let's just remember to always stick a little square on our unit. And that way we don't have to think, is this US or is it metric? Which one am I supposed to do when? It's lazier and it's easier. Just put a little square on your units. Perimeter, not square units, right? I'm literally just measuring the length around a room, but area, square units. This room, and it's been a while since I've seen the dimensions of it, I believe it is 20 feet side to side, and I believe it's 26 feet deep. So, at your seats, how many square feet of carpeting would I need if we decided to get rid of this funny looking purple carpet and we decided to replace it with something that I got to pick out? Something with math symbols on it. Just kidding, I don't need that in my life. Something neutral. 20 feet by 26 feet. Jalen's got it?
520 feet squared.
Good, and it's okay to say square feet, but we'll write it as 520 feet squared. How many have that same answer? Area of a rectangle seemed pretty easy. And area of a square, the same. If we had a square room, and each side of the room, let's just say, measured 13 feet. It was a 13 foot by 13 foot room. Well, you're technically going to still be multiplying like a length times a width, so to speak. 13 times 13, anyone?
13 times 14.
And you're finding it? You see how it's like, I'm doing this in my head. I got this. What is it?
29.
169.
169. So this would be 169. Now, how would we leave our units for this, Bryson?
Oh wow. Square feet.
Well, okay, square feet, we could do that, or feet squared. 169 square feet if we had that. So for the area of a square, we see it there in our book, A equals S squared. For the area of a rectangle, it's basically the same thing, area equals, but instead of side times side, since they're different dimensions with each other in a rectangle, we'll say length times width. And we just multiply those two dimensions. You see that in bold as well. Questions on formulas for area. Do we remember all of this from your elementary days? A equals LW, or L times W is how you said it. Now you know that if two things are mushed together, it means they're multiplied. And you used to say A equals S times S. Now we'll say A equals S squared. So we're moving up in the world a little bit. Look at the example problems on the next page. Look at the example problems on the next page. Now the top two examples are really stupid easy, right? The first example, we have a reddish colored class rectangle. And the formula for the area of a rectangle is A equals LW. Again, A equals LW, which means we multiply, because they're mushed together, the length, 8 feet, and the width, 3 feet. 8 feet times 3 feet, 24 square feet. See what they did there? Stupid easy? Look at the next one, the yellowy, orangey colored square. What's the formula for the area of a square, class? A equals S squared. Again.
A equals S squared.
So they squared 6. That means 6 times 6, which is, class? 36. But they also had to take care of the units, so when they square the meter, they get meters squared. And there's their answer, 36 meters squared. Any questions on that? What isn't quite as stupid easy is when they do scale drawings. And that's what they have on the next two. Look at letter C on the example page. See that green square? And if you count, how many squares is it in each direction, class? 4. But look at the little scale they've got to the side. They're telling you that every little square that you see measures 4 meters all the way around. So what you're going to do is you're going to look at the scale, you're going to say 1, 2, 3, 4. But since every one of them is 4, it's really 4, 8, 12, 16 across. Does that make sense? You count 4 boxes, but since every one is 4, it's really, class, 16 on each side. 16 meters on each side. Does that make sense? Everyone understand what they did with the green square? So they didn't square 4, they squared 16, and they got their area to be 256 meters squared. Any questions on that example? Because that's a little bit different. I don't think it's hard, but it's just different. Questions? Same thing with the blue rectangle. How big is every line you see on that picture, class? 2 units. Okay, now at your seats, count how many units across the bottom of the rectangle. Count how many units across the bottom of the rectangle. Class? 7, which means if each one's 2, then it's really 14. Okay, so it's 14 across the bottom. How many little things up?
5.
5, but everyone's 2, so it's really 10. So we're going to find the area of the rectangle using the formula A equals LW. And we multiply 14 times 10, class.
140.
But don't forget your units. Everything was, it just says 2 units. So what is the units? It's just units, and we'll say 140 units squared. Whatever that unit happens to be, we don't know, but it's squared, I know that. Does that make sense? So they can be meters, meters squared. If it's feet, feet squared. Inches, inches squared. Units, units squared. Questions on area of square, area of rectangle. All right, turn the page. Turn the page. I want you to do numbers 1 through 6 at the top of the page. So page 178, doing numbers 1 through 6. Once you finish, pencil down, look this way so I know that you're finished. Page 178, 1 through 6 at the top of the page. You might want extra paper. They don't give you a lot of room to do your multiplication. So if you don't write really small, you may want a little extra paper to do the work on. I hope so. Bryson's done. Elaine's done. Jalen's done. Griffin done? Corey's done. Elaine is hungry. Does that pencil taste good?
No.
No, it doesn't. Okay. Before the days of the fidget spinner, there was actually that's a newer thing.
That's my bracelet.
That's yours? Okay.
Yeah.
Did you also lose your lock by any chance?
Yeah. I was rushing because I was fixing to go to.
I wasn't sure whose it was. I was going to look it
Yeah,
up.
I
later.
ended up giving it. I was still late tonight.
That's a bummer.
And I couldn't pick it up.
All right, let's take a look at your answers for numbers 1 through 6. Number 1, what was the area of that rectangle? It is a rectangle. It is not a square. It's close, but it is not a square. What was that area, Kirsten?
378 yards square.
Well, not 378 yards squared.
370.
You did it again.
378 yards square.
There we go, 378 yards squared. Number 2, that is a square. And what did you get for the area on that one, Luciana?
22 decimeters squared.
Say it again.
22 decimeters squared.
Ooh, what's the formula for the area of a square?
A equals S squared.
So we should multiply 8.5 by 8.5, right? By the way, real quick, class, make sure you're listening to this. I'm talking to her, but I'm kind of talking to all of you here. That's 8.5 times 8.5, right? If it were just 8 times 8, Luciana, what would that be?
64.
So we know our answer is a little bit bigger than 8 times a little bit bigger than 8. I should get something a little bit bigger than 64, right? So we know that can't be it. So that's how we know we need to double check. Something went wrong here. Griffin?
46.775 decimeters square.
But it can't be that because again, we're looking for something that's a little bigger than 64. It can't be 46. Corey, what'd you get for number 2?
I'm still working.
Still working on it. Uh-oh. Class. A equals S squared. Kirsten, can you let him in? A equals S squared. That means we're going to take an 8.5 decimeter and square it. What does squared mean, class? Something
Multiply
times
by
itself. So we need to take 8.5 times another 8.5. 5 times 5, class.
25.
Carry the 2. 5 times 8 plus 2.
42,
Put in the 0. Don't forget the 0. Multiply the 8. 8 times 5.
40,
Carry the 4. 8 times 8.
36,
64 plus 4.
68.
66. 64. 64 plus 4 is 68. Thank you. And then we'll add 5, 2, 12. Carry 72.25 decimeters squared. How many did have that answer? Ooh, only Jalen. All right. Questions? What went wrong? We just multiplying. We don't want to multiply. We've been doing this all year. All right, number 3. For redemption, Luciana. We're on page 178, Michael. Number 3, Luciana, what was the area of that rectangle?
2,700 millimeters squared.
Good. How many realized you could just knock off the 2 zeros, say 3 times 9 is 27, then slap the 2 zeros back on to get 2,700 millimeters squared? Number 4, another rectangle, 4.2 feet by 3 feet. What was that area? Griffin for redemption.
12.6 feet square.
12.6 feet squared. Number 5, we have a square with a 1.9 inch side. What did you get for that area, Corey?
76 inches squared.
Well, 1.9 is a little smaller than 2, right? And 2 times 2 would be,
4.
so we got to get something a little smaller than 4, right? So that can't be it. Elaine?
2.98.
It's not 2.98, Ben?
I didn't get it.
Bryson? Elaine, or Jalen, excuse me.
3.61 inches squared.
There we go, 3.61 inches squared, 2 decimal places in that answer. Okay, back to Corey for redemption. Number 6, 60 centimeters by 5 centimeters. What was the area?
130 centimeters squared.
5 times 60? Did you multiply, Corey, A equals LW? Did you multiply 60 times 5? What's 5 times 0?
0.
What's 5 times 6?
30.
300 centimeters squared should have been our answer. Folks, this is just multiplication. I don't understand the struggle here. Questions 1 through 6. All right, we're going to go on to 7 through 10. Now on number 7, they make it easy. Class, every line you see really is just 1 unit. But on number 8, it looks like it's only 3 units tall, right? But every line is how many units, class?
6.
6. So really, how tall is the rectangle in number 8? 18. You're going to have to figure out the length, but you can do that. Looking at number 9. They make it easy. Every line really is 1. Now, specifically 1 inch. So when you get your answer, you're going to have inches squared, not units squared. Number 10, every line you see is actually 4 kilometers. So it looks like it's 3 in each direction, but it's really, class, 12 kilometers in each direction. I do number 7 through 10 at your seats. Go back and do 1 through 6, Michael, since you're done early. Tempted to play with it. All right, several people finishing up. Let's see how we did on number 7. What was the area of that rectangle? It's almost a square, but it's not. It's a rectangle. Sam?
48 units squared.
48 units squared. How about number 8, Bryson?
180 units squared.
180?
Or yeah.
What did you multiply on number 8?
60 times 3.
60 times, oh, okay, so you counted across the bottom, you said there were 10 boxes, but each one is really 6 units, so you said across the bottom is 60, right? Up the side is 3 boxes, but you forgot you had to multiply that by 6 also,
Yeah.
which should have been 18. We should have multiplied 60 by 18, Corey.
1,080 units squared.
1,080 units squared. That's why I kind of hesitated. I wondered if maybe you just read it wrong. You didn't, and we figured out your mistake. But 1,080 units squared. Number 9, Ben, what you got?
64 inches squared.
There we go, 64 inches squared. And number 10, what'd you get for your answer, Michael?
144 kilometers squared.
Well, not 144, but 144 kilometers squared. Ben, question.
I don't really understand since there's not 144 boxes in the square.
No. Every box is 4 kilometers all the way around. So each box that you see, so this is what's called a scale drawing, Ben. So this is not like, I mean, it's obviously these aren't little inches either, right? So they're just telling you that when you see a box, it's actually 4 kilometers all the way around. So that means it's 16 kilometers squared. Each box is. And then you count 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. You could do it that way and multiply by 9. It's faster to say, well, if this is 4, this is 4, this is 4, it's really 12 kilometers. 4, 4, 4, this is really 12 kilometers. And there's your 144 kilometers squared. It's a scale drawing. Like if you were mapping out a city, you can't actually have a full-size map. You have to have a map that's smaller. And that's kind of what these scale drawings are. Does that make sense? Mm-hmm. Each of these could be subdivided 4 ways each. They just didn't do that. Okay. Other questions on 7 through 10? Take a look at word problem number 11. Read that for us if you would, Kirsten.
The footprint of One World Trade Center in New York City is 200 feet by 200 feet. What is the area on which the building stands?
I believe, by the way, this is actually built on the site of one of the World Trade Towers that collapsed. I believe the other tower's base is used as a memorial, and the one tower's base was turned into a new tower, which is this tower that you see there, if I'm not mistaken. I've never been there to see it, but that's my understanding. So if it's 200 feet along one side, 200 feet along the other side, how big is that area of ground on which the building stands? What's the shortcut, class? Ignore all the zeros, right? So you're really just multiplying, class. 2 times 2, which is?
4.
Now, how many zeros did you choose to ignore?
4.
4 of them. Put them all back. And there's our answer. 40,000, Kirsten.
40,000 feet square.
Feet squared. There we go. Questions on that? All right, look at number 12. Read that for us if you would. And I need a basketball player to read this for me. Bryson?
Okay. Coach Shankly plans to have a basketball court.
Varnished. Not vanished, varnished. Yep.
Varnish.
Varnish is a sealant, a polish you put over the top to keep the floor protected from basketball players' shoes.
Varnish and one can of varnish covers 100 square feet. If the court is 50 feet by 94 feet, how many cans of varnish needs to be purchased? If part of the can of varnish is needed, the whole can must be purchased.
All right, it's been a long time since I looked at this, but I believe those are the dimensions of a college basketball court, 94 feet by 50 feet. I think the high school court's like 44 by 86, something like that. It's a little bit smaller. But anyway, the court's 50 feet by 94 feet, right? So first thing we need to do is figure out what is the area of the basketball court. So at your seats, go and find the basketball court's total area. Go and find the basketball court's total area. It's 50 feet by 94 feet. What formula are we using, class? A equals LW. A equals LW. We multiply length times width. What do we get for the area here? Elaine?
4,700 feet squared.
4,700 feet squared. Okay, that's how much area there is to cover on this basketball court. Each can, it says, class, covers how many square feet?
500.
500, right? So to figure out the number of cans, we just need to...
Multiply.
Oh!
Divide.
Every 500 feet is 1 can. Divide by 500. But, class, I don't want to divide by 500. I can do what shortcut?
Divide by 5. Cut off the 0.
Knock off the zeros. How many times does 5 go into 47, class?
9.
With how many left over?
2.
2. But wait a second. Can you buy 2/5 of a can of varnish?
No.
You're going to have to go ahead and buy a 10th can, right? So, and that's why I said what it said at the end. If a part of a can of varnish is needed, you got to purchase a whole nother can. So how many cans does he need, class?
10.
10 cans. Questions on that? All right, no homework this evening. When the bell rings, you're dismissed. Have a wonderful rest of your day.